Okay, so you can see I'm masked up because it is COVID right now, right? But we're all remote, so we should be fine. So I'll go ahead and take this off. This was from a conference I was at a couple of weeks ago. We did some career advice with that for ShellCon, and it was a really good experience. Helped people with reviewing their resumes and also general career advice. We're thinking about adding that next week for Siegel. So if you're interested, next Friday and Saturday at Siegel, I'll be speaking. I'm one of the organizers. If you have any questions about that, please let me know. Now, things that I am or have done, I've been a sysadmin, I've been a developer, DBA, data janitor, a lot of data janitor. I have done all kinds of things in technology, and SSH tunnels have been really important. This presentation actually comes out of a Linux Journal article I did many years ago, where I was talking to some other sysadmins that I actually thought had more experience than I do, and they didn't understand SSH tunnels yet. So it's like, okay, this is a fundamental thing for what we're doing. And so I wrote an article and they accepted it, thankfully. And I've done this presentation then many times, or varieties of it since then. I am currently working as a CDE doing database stuff for Object Rocket. And yes, we're hiring. Hey, that's awesome. Rackspace is hiring as well. If you're interested in either of those, please let us know. And in fact, we just found out that they closed our office in Austin. So basically every job in Austin is now a remote job. So those of you that are not local to Rackspace or where we have an office, we've got even more openings that are available, which is awesome. And I'm working remote for them. I've worked remote for uh, a while, and therefore SSH tunnels have been really important for me. All right, I have some presumed knowledge coming into this presentation. Basic SSH usage. I'm not going to go through. I'm going to cover the basic of it real fast. You understand the file system permissions and all those other things in order to get SSH running. And then you also understand SSH key and fingerprint usage. One of the key things with that is don't just randomly accept keys. Verify your keys before you allow them. That will be really important for the tunnels that I'm talking about today. All right. SSH, secure shell. Again, you should already know that. Open SSH, the one that we're most all of us are using, is an OpenBSD project. So I want to thank the OpenBSD project for doing that. They forked the original SSH and have been maintaining it for a long time. Really appreciate the work that they're putting in to keeping this tool that we depend on in good shape for us. In fact, I have kind of news for them that I learned last night. It is an essential tool for sysadmin, DevOps, all kinds of things use SSH or use SSH under the hood. It creates secure, authenticated, encrypted connections between computers, right? So this is important. We want to make sure that they're secure and encrypted, but also that you can authenticate so you can verify who it is, and allows passing data across encrypted TCP connections. We're doing TCP, we're not doing UDP. And it does require an account on the remote machine. Again, for everybody familiar with it, that should not be a surprise. All right, now here's a basic example. Now, everybody here should understand that there's actually extra information in here. I added the -P and specified the port to 22. That is the default port for SSH. So I could leave that out, but I like to put it in there just in case somebody is completely new or they just don't realize what port it is. But it's an important thing to know that port 22 is your normal port. I will be using it a lot in this presentation. Now here's a basic tunnel. Now let me back up a little bit. I forgot to bring in a couple of my props. So I mentioned encryption, and that encryption is important. But what does that mean, right? So this is an example. It's not a perfect example, but here's an example. I have, let's say that I am sending a postcard through the mail. That is unencrypted. Anybody that sees that postcard, including all the machines that take pictures of it, can make copies of that postcard and see all the content that is on there. So if I send this magnet through the mail and I send it as a postcard, then anybody that happens to see it as it goes through will be able to see that I'm sending a GNU. And I don't know what the postage is for mailing a GNU, but whatever, right? So that's unencrypted. Encrypted in the mail example is where I take a nice envelope, I put the content, oops, I'm doing it off screen here. I put the content inside the envelope before showing it to you, right? That's the important part. Don't show it to people when you're doing it. And now I send the envelope through. Now they might be able to weigh it and do other things to find out what, how much content I'm sending. But if I've got a truly secure envelope, which this is not because you can see through it, but if I have a truly secure envelope, then you can't see what the content is in there, right? And that is what encrypting is. Encrypting is going through and obscuring the contents mathematically on your side so that as they ship from your computer to the other computer, all that can be seen is the encrypted version of it that cannot be decrypted is the theory, right? And we're in good shape for that. And then it gets decrypted on the remote side. So creating a tunnel is not really creating a tunnel though, because if you think a tunnel, you got this pipe, right? And you're sending stuff down the pipe and things are going through. But really what's happening is every single packet, whether it be the GNU or my plug magnet, we are going through and encrypting that data as a whole, and then we're still sending packets. So it's more like rail cars, right? Where you have the content inside the rail car, inside the container. You can't see what's inside the container. You can just see the container. You can still see information about the container. You can see who owns it, where it's going, where it's coming from, things like that, right? And that we still have a lot of that in our TCP packets. There's still a lot of information there about where it's going to and from, but the goal is that everything inside the container is locked down so that people can't figure out what it is by observing. They can't take a copy of it and find out what it is because all they get is a copy of that is of the encrypted information, right? So that's what we're really doing. We're not building a tunnel so much as we're building a rail line with encrypted rail car content in the rail cars. All right. Now, in order to build that tunnel, though, this command will do that. The dash capital L says create a local tunnel. We'll talk about what local means versus remote in a second. And I'm saying from that first port, the 2222, I want to build a tunnel from that port on my machine, on my local machine, to firewall.example.com, and then to port 22 on that machine. So the SSH port on that machine. And I'm going to do that. I'm going to connect to firewall.example.com. So the second half, cool, if we can see mice here, there we go. So I'm actually connecting there, whoops, to firewall.example.com, and it's saying create that tunnel. Now, those are the same machine name. So firewall.example.com says, hey, who's firewall.example.com? Oh, that's me. I'll make it to my port 22. And one of the keys there is I'm now making that connection on localhost. So the tunnel is from 2222 localhost, so 127.0.0.0.0.1 on my machine to port 22 localhost on the firewall machine. So 127.0.0.1 from firewall's perspective. So then I can enter that tunnel using an SSH connection. Again, I'm specifying the port like I did in that very first example, but this time I'm specifying port 2222. And again, I'm talking to localhost on my machine. Now, what happens when I make this SSH connection is that SSH says, okay, I'm going to talk to my machine, me, and I'm going to talk to port 2222 on my machine, and that's where I'm going to make the connection. But then it follows up that tunnel and it actually talks to the SSH daemon, the SSH server on firewall.example.com over firewall's local host. So this tunnel is not talking to an external interface on either side. It is talking to localhost on both machines. Now here's a basic diagram of what's going on with that. Oh, I forgot to change one slide. All right. So anyway, so here we have a basic machine. This dashed connection is your SSH tunnel. That's the original SSH connection that is going from my machine to firewall.example.com. And then the green part is the tunneled connection that the dash L is making, the dash capital L. And then finally, with the SSH-P, where I'm specifying localhost, that's the blue connection inside the tunnel that is making that SSH connection. All right. So then we can also do that reverse. So L is local and R is remote or reverse, whichever way helps you keep track of it or visualize what's going on. And for this connection, I'm actually making a connection from that remote host a tunnel from that remote host back to my local host. So now anybody on that remote host would be able to connect to port 2222 on the local host and be able to then connect back to my SSH server on my client machine. So it's still local host versus still local host 2 is still interpreted the host portion, the remote machine that I'm connecting to. And then on host 2, you can see the prompts. I've got host 1 and host 2. On host 2, again, I can connect up to port 2222 on localhost and connect back to my SSH daemon on my client machine on host 1. Now, an important part of this is that you need to know what those keys are, the fingerprints for the SSH daemons you're talking to. Don't have time to go into it in this talk. In fact, that could be several 3-hour talks. SSH key management can be, and verification can be detailed. So you need to make sure you know that ahead of time before making this connection. Please don't just accept it, because that opens you up to man in the middle, especially when we get to the point where I talk about you can't trust that remote machine, where we're throwing tunnels and stuff. And verify that, but you also then need to go through and make sure there's an entry for localhost and that port for that particular fingerprint / key that you're going to talk to. All right. Now here is an example where I'm simplifying this by getting rid of the extra host 2, because we're really talking about who does that remote machine think it's talking to. In this case, I want to talk to localhost. So instead of saying, hey, Fred, talk to Fred, I can say, hey, Fred, talk to self. Localhost is a way of saying talk to self. Makes it a little bit easier to understand, I think, and it also makes it a lot shorter and everything. But I like to give the full example with the host names, because that's actually an important difference. It just, if you give it itself, it will then talk to itself. All right, now throwing a connection. This is kind of what I was talking about a second ago. We need a couple of extra, we don't need a couple of extra options, but I threw a couple of extra options in here. We'll talk about those at some point. So in this case though, this is, by the way, the same time tomorrow, Dave Stokes, I think, is talking about MySQL. This is, so going in here. All right, so going to the database, I'm saying firewall.example.com, instead of port show tunneling port 22 for SSH, I want to tunnel to the database instead, and I want to tunnel to the database on a different machine, on db.example.com, right? Hold on a second. So now what I'm doing is on my local host where my client is, I'm making a connection from 3306 across firewall.example.com to port 3306, the external portion of it though, because firewall is talking to the external port of db.example.com. Now, an important part of this is the part that is thrown, the connection from firewall.example.com over to db.example.com is not encrypted. SSH is not encrypting that. There's no client connection there. It's just throwing TCP packets across the wire, right? So keep that in mind when you throw a connection. The SSH tunnel is not protecting that portion of the connection. The part up until then, from my client to firewall.example, is still encrypted, but from firewall.example to the database, that is not being encrypted by SSH. So as I mentioned, Dave is doing a MySQL presentation tomorrow. That's 3306. Etsy services is a great place to find out what services are typically run on particular ports if you're not familiar with it. All right, so let's move this down a little bit. There we are. Okay, so back to my SSH tunnel diagram. The first part from my machine to the gateway is still the same. We haven't changed that. We got the original connection, tunnel connection, and the SSH connection coming across it. But then from gateway to machine 2, we have the forwarded connection. And again, that is not encrypted. The forwarded portion of it is not encrypted. Now, if I make a client connection across that to a server on that other machine, where the client connection to the new server is encrypted, then I get encryption that way. In this example, I'm using SSH to do that, so it would still be encrypted. So we got the examples here where I'm going through and doing stuff. The things with the equal signs are encrypted. The things with the dashes are not. And those typographers got to me. Oh. All right. Woo! Don't know what I just did. Return to slideshow. Cool. Remind me not to do that again. All right. Now we can also make a dynamic tunnel. That's the dash capital D. And what that allows me to do is say anything that's using, it's a SOX proxy, anything that then connects to the SOX proxy will appear to come from the remote machine. So if I make a dynamic tunnel to firewall.example.com from my client, so that now I have a connection inside the network, right, at example.com, the mythical corporation that we all know and love, right? So if I make that connection in there, I now have a connection inside the network. I can get to resources that are only available inside the network. If I use Foxy proxy, for instance, or many other SOX proxies, I can then make client connections on my local machine that appear to be coming from the internal network. So as long as firewall.example.com has access to them, so for instance, if there's a www.internal.example.com that is only available from inside the example.com corporate network, then I will be able to get to that even though my machine isn't in the local network. And the connection from my machine to firewall.example.com is still encrypted by SSH. Right? Now, the part that I'm throwing that's going from firewall.example.com to the internal web server is not encrypted by SSH. So make sure you've got HTTPS set up properly on that web server if you want to make sure things that are on the server are encrypted. And that should always be the case at this point. All right. Now, I can also do a double reverse. So what happens if I'm on an internal network that you can't, a machine you can't get to, and I need to talk to another machine that's also on an internal network. So they can't SSH to each other directly. I need some way to get in between. So I can use a trusted or untrusted, and this is where I was talking about where you don't trust things, machine in the middle that both of them can connect to and build encrypted tunnels both ways off of that machine. So in the first one, I'm creating a tunnel from my local host port 3333 to port 3333 on that firewall, but also from that firewall back from port 2222 to my SSH server. So now anybody on that firewall can SSH to my SSH server on my client, right? They still have to have an account. They still have to be able to authenticate. Hopefully you've locked down your SSH server. You're not just saying, oh, let anybody connect with any random keys, right? I'm not even certain you could set that up in SSH. I've never wanted to find out. Never wanted to try it. Then on the other host, on host 2, I do a similar type of thing, but now I'm creating that tunnel from 2222 on localhost to 2222 on the firewall. But when I connect to 2222 on the firewall, I'm actually connecting to that reverse tunnel from host 1. And I create a reverse tunnel from 3333 on the firewall back to host 2. So now that local forward from host 1 is actually connecting to the tunnel that's coming back to host 2. So now when I go through, and I think I've got this in here. Oh, I've simplified it with localhost, so it's a little bit easier to read and fits all in one line. Oops, and I did leave out the client connections. But on host 1, now if I SSH to port 3333 on localhost, I'm actually talking to the SSH server on host 2. I'm going across the firewall, but my client connection is to the SSH server on host 2, and I will get the fingerprint for the SSH server on host 2. If I'm not, I'm being man in the middle. Plain and simple. I'm getting the SSH server on host 2 through that tunnel, even though I'm going over another machine. In fact, somebody on that machine on firewall.example.com could be looking at that connection, right? So they have root. They could have gone through and done something with the SSH daemon. There's a bunch of things they could do to go through and compromise that tunnel where they could review data. This is why I say whether that machine is trusted or untrusted. In fact, let's say that it's untrusted. Let's say that last week, your team played the network security team in softball, because that's a safe thing to do right now, right? And you kicked their butts, and they're pissed off at you, and they want to take revenge for whatever reason, right? Well, they've got ways of messing with you on this. But if you verify that connection, that is a secure connection from your client to that server on host 2, and they can't look at it. They can kill it. They can prevent you from making the connection, but they can't intercept it. They can't read it. They can't decrypt it, even though you're going across their SSH daemon, because you're making a client connection from your client to the server, from the client on host 1 to the server on host 2, or vice versa, from the client on host 2 back to the server on host 1. And as long as you verify your keys properly, then you're making connection. And I've had people say, "Oh, that's not true. If the machine is compromised, it's compromised." Yes, because if that's not true, SSH doesn't work. Every time you make an SSH connection across somebody else's switch, across somebody else's router, across somebody else's firewall, every time you're doing that, you're making an SSH connection across untrusted equipment. If SSH isn't secure from that client to that server across this tunnel, then it's not encrypted. It's not safe to make across the internet. Plain and simple. So you've got to verify those keys and make sure you're not getting man in the middle. All right. We can also do graphical stuff. So you can use SSH-Y. And if you do that, you can shoot xterms and other graphical clients back in. So one of the things I do for this is I will go through and create containers that are one-use type of things, or something where I want to keep something isolated. So create a container for my banking stuff, and then I can SSH-Y into my container, and I can shoot the Firefox display back to my desktop, so it's convenient to use. But I'm keeping it isolated, and all the access it has isolated to just within that container, to the extent the containers are secure and all that, blah blah blah, right? And then you do need a -new -instance, and I suggest calling up Profile Manager as well. It just makes it easier in order to get that, because otherwise Firefox gets helpful and tries to open it up on your local machine, which is inconvenient as heck. All right. Okay, sandboxing VM, same type of thing. Yeah. Oh, so far I named it there. JavaScript is dangerous. All right. So keys, you can generate a key. All the examples say ID dot and the key type. Give it a real name so you know what you're talking to. If you, as a sysadmin or a developer, if you don't have a bunch of different keys on your system, you should. Plain and simple. And you can put authorized keys. Again, you should know that. And then a convenience wrapper script is nice. It's called SSH copy ID, and that will copy your key over for you and make sure the permissions are correct and everything like that. So that's actually really convenient. I don't actually use it because I always forget about it until after I put the key in place. But the times I remembered, it does save me several steps. Service example. So I gave this kind of earlier with the MySQL. So again, we're doing the local tunnel that goes across firewall.example.com to the database. Reemphasize again, the part going from the firewall thrown to the database is not encrypted by SSH. Now, when I connect over from MySQL to localhost, I actually have to do something new for that MySQL connection. I just can't just say localhost import 3306. I need to tell it what protocol to use. I need to tell it to use TCP. The reason is a little MySQL quirk that I didn't discover until I've been giving this example, this presentation a bunch of times. But when you use localhost, MySQL tries to use UDP socket instead. So you can just say 127.0.0.1, and then it'll default to that port and using TCP, or you can specify the protocol, whichever works easier for you. Now, if you want to make sure that MySQL connection, that database connection is secure, make sure that you've got a secure SSL connection from your MySQL client on your local box to the MySQL server itself. Service examples. So here I'm tossing 143 and 993 for IMAP. I'm also tossing 25 for SMTP. So you can build those up, and then your mail client and everything could talk to localhost across SSH in order to do stuff. That's actually what I do. I set up SSH tunnels to my mail server and do it this way, and that way I know I've got a secure connection, and everything is going across that one single secure connection. It reduces the number of things I need to open up. Then web example. So here we're going to use a localhost or local port 8080 to talk to the web server, as I mentioned. I should call it www.internal just to make it a little bit easier. When you do that, though, in modern world, we have multiple web servers. In modern world being the last 30 years, we have multiple web servers running on a different domains running on a web server using virtual servers, etc. So you can use with different tools. The example I give here is links. You can tell it an extra header to say, hey, this is the host I was trying to talk to. So instead of trying to, coming across as localhost or as firewall.example.com, we'll give it the host name that I want to talk to. So that simplifies things. Got a dynamic firewall example given again. Mentioned Foxy Proxy. I've taken that out of the presentation, so go learn it on your own. But Foxy Proxy is a great add-on for Firefox. I think it's available for other browsers as well. I just don't check. But it allows you to specify different things. At a previous job, when I first wrote this, I was working at a place where I needed to get on 3 different corporate networks all at the same time. So I had 3 different tunnels set up with uh, um, SOX proxies, and then I went through and used Foxy proxy to set up rules. So when I said, when I'm talking to Corp A domains, it goes across this proxy. When I'm talking to Corp B domains, it goes across this Foxy proxy. And then Corp C, I wasn't even domains. I just had to say, okay, these 3 boxes. If I'm talking to either of these things, they go across that other proxy. And that way I was able to keep it all straight. And none of my content then was going across the net. So if I was sitting in a cafe or something like that, I didn't have to worry about it. ASCII Puffy. So Puffy is the mascot for SSH. I've got something I've had for a while. And then also this guy. So anyway, I like Puffy. It's fun. Someday I'll get a really awesome Puffy shirt. Okay, we got some time still, so I can go through the configuration tips as well. Hold on a second. So you can specify multiple known host files in SSH config in a newer SSH client. Newer being the last 3 or 4 years or something like that. But at a place I was working not too terribly long ago, we had an SSH on the distro we were using that was too old to have this, which is where I discovered because I really needed it. um, but most systems should have that nowadays. So one of the reasons I was using, or the reason I was wanting to use this, was because we were using Puppet for our deployment there. We were actually using multiple Puppets. It was fun and exciting. And I would then grab all of the SSH keys from the Puppet information and throw that into a known host file because we were doing dynamic creation of hosts. It wasn't that much turnover, but still a decent amount of turnover. And because the way we were doing things there, I still needed to SSH to boxes on a regular basis. They changed their infrastructure, so that was no longer the case. But at the time, I was still maintaining the older infrastructure. And I didn't like all of those random hosts uh, um, going through and polluting my known host file. But I also wanted to make sure I was verifying the key, right? I didn't want to go through. In fact, it was a good thing I did because at some point, let's just say that the place I was working for had an SH in their uh, name, and if you left that off, suddenly I was getting connections to China. Um, so that was a bad discovery, but luckily I was checking hosts and I was not sending any data across to them because it came up and gave me a warning that I was connecting to a host with that had where the key had changed. and I was able to catch my typo and notify InfoSec that we had an issue. All right. You can specify per key restrictions and authorized key entries. This is really awesome. So when you authorize a key to say, okay, this key is allowed to talk to my host, wherever that host is, you can go through and do things. So for instance, if you're setting up an automated task to go through and do backups, you probably don't need X11 forwarding for that, right? Hopefully you don't. If you do, I don't want to know. I really don't. But for an automated connection, you don't need any of these things. You probably don't need port forwarding. You might need that. I do some weird things where that could be possible. No agent forwarding, you probably don't need that. If you do, there's other ways to fix that, hopefully, right? So turn that off for those connections so that if somebody compromises the machine that's making the backups, they can't use that to get extra access to the machine you're backing up. Right? You can also force a per key specific command. Now this is important. Per key. So if you have 3 different backups you do of a remote machine, and they all use different commands, or you connect to for there's 3 different reasons. One for backups, one to kick off some interesting crons where you need to ship data over, and one just because it's Tuesdays and that's what you do, right? You'll need 3 different keys for one for each of those connections. But you can then specify the host name, and then it doesn't matter what command is run from that remote machine. It will always run the command that's specified in the authorized key file. Now, I think I skipped over something. We'll get to rsync in a second here. And then you can also do per key network restrictions on that as well, so you can restrict where it's coming from. I mentioned earlier I'd get to the dash capital N and the dash F. The dash capital N says no remote command. I'm not going to run something. By default, when you SSH to a machine, it gives you a shell. It gives you whatever the default shell for that account on that remote machine is. So if your default shell there is bash, then you get bash. If your default shell is ZSH, you get ZSH. If your default shell is bin false, you don't get a login, right? But dash N says don't run a remote command. Dash F uh, says to background off after authentication. So you still get prompted for authentication if you need to be able to type in a password or a key or something like that. But then it'll go into background after that. A cool thing with SSH, if you're having trouble with the connection, it's not working out, you can't figure out why it's not working, you can use a dash V to give you more verbosity, and you can do up to 3 of those, and it can get pretty prolific at that point. So you can do those. Dash G, I discovered recently, capital G, shows what configuration would be used for the connection. Oh, that is also really awesome for debugging when things are going wrong. Or just to verify that you're getting the connection you want. Just because it's working doesn't mean you're getting the one you wanted, so you can check that. And the dash lowercase t for those of us that are sysadmins, especially across sketchy networks. That says to force a pseudo terminal, even if you're connecting up to something that doesn't. So if you go through an automatically launched screen, you'll want to use that in order to get the connection. And I left the T out of the actual example. Wow. All right. And then dash O, you can specify a bunch of different command line options. Shell variables. These are important for, again, for system inside. PS1 on your remote machine, make sure it's got a prompt that has enough information. I worked at a place where we name the machines the same on every network, in every data center. So I had box 1, box 2, box 3 in each data center. So when I connected up, it just said box 1. I didn't know where in the world I was talking to. So I set up PS1 to also include the DC in there, show me the pop so I could know what country I was in, right? And then SSH auth is used by the SSH agent, so you can connect to that SSH auth in order to reuse connections for an agent from a different shell. Tools, I mentioned SSH copy ID. SSHFS allows you to mount a file system over SSH. It's not the fastest way to do that, but it works, and I use that occasionally. Mostly just use rsync to copy data back and forth. And this is the part I was saying in an update. So LWN posted an article, I don't know when they posted it, but I saw it last night, saying that SCP is now considered dangerous. And they give some examples of some places where it can be compromised. If you own the client and you own the server and you know what you're doing, from what I could see, it looks like you'd be fine. However, it might be a good to just right now start getting into the habit of using rsync instead of SCP. Somebody is working on an SCP re-implementation that won't have those problems, basically doing SCP over SFTP instead. But hey, rsync's there and it works great. So use that. SFTP, I don't like FTP, so I'm glad to not use it. But for those of you that works, go ahead. Um, Auto SSH is for automatically building connections. So if a machine reboots or if your connection goes down, Auto SSH will rebuild it. You need automated authentication, so you need a key that you can use without interaction, but you can do that. But do not use SSH keyscan. It looks like a really cool tool. It doesn't verify the keys. All it does is go and say, what's the public key? It's great for auditing, right? Is that machine still the machine I think it is? go through and make sure that the key hasn't changed. But don't use that to grab the key for the first connection. All it does is connect to the SSH server and grab the key and the fingerprint off of it and note that. So it's not actually doing any verification whatsoever. You need to verify that out of band a different way. All right, some extra stuff. You can copy data across. So here I'm SSHing to firewall.example.com. On firewall.example.com, I'm running sudo tar to back up etc. And then I just throw the data into a pipe, right? Just a whole bunch of zeros and ones going across, right? And then on this side of the pipe, I'm running tar again to go through and extract the data out of there. So I'm basically tar to tar piping it, but I'm using an SSH connection to create that pipe. And then an example that I don't need to use very much anymore because we've gotten much better, but it used to be that we would run out of resources on remote machines. It doesn't happen so much anymore because we've got better process management and stuff like that. Not to mention machines are just so much bigger. But you could get to where you couldn't create a shell on the remote machine, but you could still SSH it and run commands. So I would SSH that remote machine, run a process table, and then pipe that back to my local box. Use T so I capture it, one, right? Don't look at it once and then lose all that data because you might not be able to run it again, or you might need to be very specific. Throw it into a file on my local machine, and then I can go through and look at it with less, or go through and look at that file specifically. So even if you can't get a shell, you might be able to run other commands and find out what is using all of your processes by looking at that process list, and then SSH in and do a kill on that process ID. I have saved a lot of machines doing that. Again, not in the last 5 or 6 years, thankfully, because we're in better shape. rsync, I mentioned. You might need to specify to use SSH as the connection for rsync. And then go forth securely and play the home game. All right, or the office game as it might be. Do we have any questions, comments, corrections?
Hey, Hans, thank you very much. A very good discussion. Yeah, we have actually a lot of questions in the QA window. So maybe you want to go through these questions one by one. Some of these you already answered, but there are others that I think need some answer from you.
All right, let's see if I can get to the QA question thing. Is that it? No, that's not it. Oh, I got to stop sharing screen in order to do that, I think.
I can read
Right.
it for you if you like.
Okay, I got a couple. Here we go. Suggestions on managing persistence with connections and throwing. So I don't do anything with systemd, but as far as managing persistence, I use auto SSH for that. I don't do very much with persistent SSH connections, but I do use it for a couple of specific situations. Specifically, I have it set up for those reverse tunnels for people that I help that are behind an ISP firewall, so that their client, when they reboot their machine, auto builds a connection back into my machine that I can then connect. So the reverse tunnel I was talking about, that allows me to get past their firewall by talking to a local port on mine. And I use auto SSH to build those. In fact, I got enough paranoid about it that I build auto SSH in at least 2, if not 3 different ways on those remote machines in case something goes wrong with one of the other ones. So redundancy to make sure I've got access so that I don't have to drive somewhere or hop on a plane as the case may be. For the -Y, which side processes the graphics? I have no idea, actually. I really don't. Um, so some of it I'm pretty certain depends on how it's done. So I've noticed a couple of tools go through an automatic. They kind of build a moving graphic. If they do that through just a constant update on the server side, the SSH connection gets killed. It could actually lock up your desktop to some extent, waiting for all that to process. If they do it within HTML and CSS and all that, then it works pretty good. So I'm pretty certain that that rendering is taking place on the client. X is weird client server. I can't even think well enough to say which. On the desktop that's showing it is where it's being rendered, I think, but I don't know for certain. And if that performance is important, look at X2Go. I didn't add it into my presentation, but it does a better connection for graphical stuff. I just use the -Y for the most part because it works fairly well. X2Go will also allow you to throw audio. So if you need to watch a video on a remote machine, you can actually then pipe that back to your local box. In fact, that's how I use Zoom most of the time. I SSH into the box that has the one place I've got Zoom installed, and I throw it back to my desktop. I didn't do it here because I didn't want to risk displays, also or risk delays and stuff like that. Also, my regular desktop is a 60-inch monitor. I didn't want to share that entire screen. Using copy ID, I have to, oops, there we go. Have to pay an SSH first. You have to pay an SSH. I'm presuming you didn't do and run an SSH add. Well, SSH add is adding the key to your agent. And before you run SSH copy ID, you haven't copied the key over to that remote machine. So you'll need to authenticate using a normal mechanism first. Once you've authenticated, so password, key, whatever it is that you have. Well, actually, key wouldn't because you're using that key. Unless, actually, I do this because, like I was talking about, where I'm setting up keys for specific tasks. So I've already got a key into the remote machine, and I use that original SSH connection to play over the new key for the one-off task type of thing. But you need to connect for SSH copy ID, connects over SSH through some other mechanism to begin with, and then it'll copy your ID. Now, if the ID that you're copying over will then become your primary mechanism, then that'll put it in place for you. And I think we just hit time.
Yeah, Hans.
Yeah.
Unfortunately, we still have a number of questions that probably we are going to answer on Slack channel. We hit the
Okay.
time.
Can you grab a copy of those before we drop out, or ask me in general? And I'm glad to answer. And I'll be here all weekend, right? So please remember to tip your wait staff and thank the volunteers and organizers that are putting this on. But I'll be here all weekend. And now that my presentation's done, I can pay attention to general.
Very good. Yeah, we will make a copy of the questions. Thank you so
All
much
right.
once again, Hans.
Thanks a lot.
See
Enjoy
you.
the conference.